We know that we can use the distributive property when we want to multiply two polynomials together. When we complete that multiplication, we end up with one polynomial at the end. In our answer here, 6x to the 7th plus 15x to the 5th is a single polynomial, and we got that from our multiplication. But suppose you only have a big polynomial, such as 6x to the 7th plus 15x to the 5th, and you want to break that down and get it back to its individual pieces, 3x to the 5th times 2x squared plus 5. It's almost like you've made the puzzle and now you're taking it back apart. We can use a process known as factoring. Factoring involves taking a polynomial and breaking it down into a product of smaller pieces, like we had in the beginning. There are several techniques you can use for factoring. Each type of polynomial has a trick that you can use, and in today's lesson, we're going to see how we can factor by using the greatest common factor. In example A, we're going to see how we can use the greatest common factor in order to factor a polynomial. Now, the process is very simple. All we do is look at each term and see if all of the terms have anything in common. That would be what we would have distributed, and we'll put outside of the parentheses. I'm going to do it step by step here. It might make it seem a little bit more complicated. I just want you to see what's going on as we work through the first example. We begin by looking at each term, and we have an 8x to the 3rd and a 4x to the 4th. We begin by looking at the numbers. We have an 8 and a 4. Is there any number that goes into both 8 and 4 evenly? That's right, 4 does. So what we're going to do is we're going to write down a 4 with a set of parentheses. Now we'll divide each number up there by 4. 8 divided by 4 is 2, x to the 3rd, plus 4 divided by 4 is 1, x to the 4th. Once we've taken care of the numbers, the coefficients, we can look at the variables. Do the variables have anything in common? Well, we have x to the 3rd and x to the 4th. Notice we have x's in both of those. We have 3 x's in the first term, 4 x's in the second term. I can only take 3 out of the first one, and so what I'll do is I'll take out x to the 3rd. Now I divide each term by x to the 3rd. That leaves inside 2 plus x. So in factored form, we have 4x to the 3rd times 2 plus x. Do you want to check your work? Just use the distributive property, and it should get right back to 8x to the 3rd plus 4x to the 4th, where you started. In example B, we really have more of the same thing with another variable. We have 3ab squared minus 6a squared b. We'll begin by looking at the coefficients, the numbers. Notice that the number 3 goes into both 3 and 6. So we take out a 3, and what's left inside? Well, we divide 3ab squared by 3. We're left with ab squared. And then we divide the 6a squared b by 3, and we're left with minus 2a squared b. Remember, you can always check each step by using the distributive property. If I distribute the 3, I end up with what I had in the beginning. Now let's take a look at the variables. The first thing I notice is that both terms have an a in it. The first term has a to the 1st. The second has a squared. We can take out only the smallest exponent. Because we have a to the 1st as our smallest exponent, we'll take out an a, and then we'll divide both terms by a. I also notice that I have b's in both of those terms. Well, let's see, I have b squared and b to the 1st. b to the 1st has the smallest exponent, and so I'll pull out a b. Now I divide each side by b. When I've done my division, I end up with simply a b minus 2a inside the parentheses. In example C, we have 2y squared minus 4y. Please find the greatest common factor and factor this polynomial by using the method that we've seen. Please pause the video here and try example C. Let's see how you did. The greatest common factor is 2y. Both of the numbers in our original polynomial are divisible by 2, and they both have y's in common, with a smallest exponent of 1. When I divide each term by 2y, I am left with y minus 2. Example D is also for you to try. Please find the greatest common factor and factor this polynomial using that method. Please pause the video here and try example D. Let's see how you did. Greatest common factor is xy. Both of the terms have x's, both of the terms have y's, and the largest exponent on each of those is 1. When I divide both terms by xy, I'm left with x squared y minus 3 inside the parentheses. As a final example for you to try, we have a trinomial. Please use the greatest common factor in order to factor this expression. Please pause the video here and try example E. Let's see how you did. There were no numbers that went into 4, 9, and 12 at the same time evenly. That left us with variables a squared b as the greatest common factor. Divide each term by a squared b, and I'm left with 4b minus 9ac plus 12bc inside the parentheses. So here's what you need to know. If you're looking to factor a polynomial, one good place to look is to see if there's a greatest common factor. If the terms all have a number in common or variables in common, greatest common factor can be a very easy way to make an expression simpler. And that's everything you need to know about factoring by using the greatest common factor.